We are live. Okay, so today's date is 9/2/2021. Okay, today's objective. We're going to be taking a look at linear functions, but we're going to be looking at the line of best fit. Okay? So sometimes things don't line up perfectly. I mean, for example, if we were to take a look at everybody's height and age coming in here, for example, everybody's height and age coming in here, I doubt if we'd have a straight line, right? Or if we took a look at, say, temperature over this last summer. I mean, it'd be like all over the place, right? So some things don't line up perfectly, but we can still get some kind of an equation. So if I take a look at this one, they aren't completely lined up, close. So what we want to do is linear today, which we know we'll start with y equals mx plus b. We've seen that. And because we're going to call it a function, what am I going to change? F of x, right? So we're going to really say, let's go f of x equals mx plus b, right? Good. So y f of x, kind of the same thing, unless I want you to talk about it as a function. Okay, slope, we know what slope is. Slope is rise over run. But we have a formula, and we've learned a formula back in geometry. And the formula has to do with y2 subtract y1 over x2 subtract x1, okay? Now, there's a thing called a correlation coefficient. And we're going to talk more about this when it comes to Tuesday, okay? But for right now, today, if it equals 1, so correlation coefficient, I'll say it and I'll show it. I'll say it and I'll show it, okay? It's a number. Correlation coefficient is a number. It's a number between 1 and negative 1. What does it tell you? 1 and negative 1, okay? If it's 1, the points are perfectly lined up. Perfect. It's a 1. 100% of the lines are made up, okay? If it's a negative 1, it's just going downhill. But all the lines are perfect, 100%. So if it's a negative 1, but if it's a 0, what would a 0 look like as far as points? Anybody, what do you think? Just a 0. What would a 0 look like? All over the place, right? Like somebody took a shotgun. Does that make sense? Right? Points are all over the place, right? No correlation, right? For example, okay, definitely, you know, I could say that short people have higher IQ. So if you're tall, you're dumb. Now, does that make any sense? No. And I bet if I did some kind of like if I took an IQ test and measured something, would I have any correlation? No, of course not. So the graph you'd see would be all over the place because there's no correlation between height and intelligence. You guys agree with that? Okay. Now, why is correlation so important? Well, take a look at what's going on with the COVID shot these days, right? Some people are taking the shot, some people aren't. We're not going to get into that, but you know, in science, the correlation is really important because if you were a scientist and you said, well, I'm not taking that shot unless you can show me good data. So good data would be a correlation of 1, correct? If the correlation was 0, I'd say, no thanks, man, I don't want that shot, right? Does that make sense? So these numbers are super important in science, okay? Now, this one's close to a 1, but it's not quite a 1. I mean, if I tried to fit a line in here, you know, it's a little off. So I would guess, I'm just going to guess, and I'll say R might be about 0.9. You guys okay with 0.9? 0.9, so I'm just a guess. It's just a guess. I'm going to use a calculator on Tuesday to get the exact number, okay? About 0.9, okay? If I looked at this one, it's definitely negative because it's going downhill, right? Maybe 0.8. It's not quite as tight as the others, right? So it's just a guess. I could be wrong, but I'll let a calculator tell me on Tuesday. But I'm going to guess a negative 0.8. I mean, it's not as tight as the first one. They're a little bit more off. But this one, what do you think this one would be? Close to 0, right? Yeah, I might say it's a negative 0.1 because you might say it has a downward trend. I might say R might be a negative 0.1 again, but that's just a guess, okay? So the correlation coefficient is really important in science. It is. If you have a bad correlation coefficient, bad data. Don't mess with it. If you have a good correlation coefficient, then the science is usually sound. Now, this one. Let's go ahead and do example 1. Let's find the equation. So if I want the equation of a line, then I'm going to need to use that formula up there, right? So the first thing I'm going to do is draw the line of best fit. Okay? The line. Did I forget the word line? I get talking the line of best fit. Sorry about that. So I'm going to try and just take my ruler. Just try and fit it in. I think it's right about there, okay? So I'm just going to try and find the line, and then after I find the line, I'm going to try and find 2 points that are close to the line. Okay, any 2 points. Okay, I think I'm going to pick maybe this point and maybe this point. Okay, so I pick any 2 points. Well, you can pick any other points, but I just like those 2 points. Okay. Pick any 2 points. I like those 2 points, okay? So this point looks like it's about 1, 2, 3, 4, 1, 2, 3, 4, 5. So I've got maybe a negative 4, negative 5, right? 1, 2, 3, 4, 5, 6, 1. And I pick 2 points. If I have 2 points, I can find the slope. So the first thing I'm going to do is let's use this formula to find the slope. Okay, so the slope formula, let's see. Every point to use this formula, it's got y's and x's in it, right? This formula's got y2's, y1, x2, x1. So every point's got an x and a y, right? Every point's got an x and y. This could be my first point, x1, y1. I'll let this be my second point, x2, y2, right? First point, second point, doesn't really matter. It could be, this could be my first point, second point, does not matter. But I just chose this one to be the first one, and this is my second one. Okay, so then I'm going to put those into my formula. Okay, so I'm going to go, all right, say m equals, let's see, I'm going to go, use my formula, I'm going to go y2, so I'm going to go 1, I'm going to use my formula, I'm going to go 1, subtract y1, which is my negative 5, double negative, over, I'm using my formula, x2, which is got to be the 6, right? x2 is the 6, minus x1, which is my negative 4, okay? So I'm using my slope formula. I picked any 2 points. I need to plug the x's and the y's into the formula, simplify, double negative, right? So I get a 6 over 10, or it's about 0.6. My slope is about 0.6, okay? I'm not done. So if I need the equation, I need more. So if I need the equation line, I'm going to use this. Okay? So if I need the equation line, so the first thing I did is I found the slope. The second thing I'm going to do is use my equation. Y equals mx plus b, okay? All right, so I've got my y value. I could use either one of these. I've got either point. Okay, now look, I could use this point or this point. It does not matter. Which one do you like better? The first one or the second one? Does not matter. Which one do you like better?
Second one.
Second one because of the pauses, right? I agree. They both work. So that's a x and that's a y, right? That's an x and that's a y. That's an x and that's a y. Okay, so the 6 will put in for x, the 1 will put in for y, and the m is 0.6. So let me substitute my
6, my 1, and my m into my equation. So instead of writing y, I'll write 1 because it's my y value. Equals, instead of writing m, I'll write 0.6 times, instead of writing x, I'll write my x value, which is 6 plus b. And now I'm just going to solve for b. Okay? All right, so I'm going to go 1 equals, what's that, 3.6 probably? Minus 3.6, minus 3.6, what is that, a negative 2.4, negative 2.6, okay, all right, good thing I use. So my equation, I'm going to squeeze it over here, is f of x equals, f of x, right? F of x is a function, f of x equals, or y equals, I know my slope is 0.6 plus or minus 2.6. Okay, that would be an equation of that line. We're going to do this again on Tuesday. Okay, so if you're a little confused, a little bit lost, we're going to do this again on Tuesday. Okay. Now, example 2, we kind of did these already, didn't we? Okay. What's the slope? What's the slope? Example 2. What's the slope? Slope's rise over run, isn't it? So what's the slope? Looks like it's up 10 over 2, right? Up 10 over 2. Which is 5. Okay, everybody listen. Everybody listen. It seems like every time I give this quiz, every year, half the class misses this. But you're not going to because you're listening, right? It's a bummer because it's an easy question. Words. What does slope mean in words? The words are in front of you. The words are here. Weight per year, right? Do you see it? Because if slope is rise and run, the answer is weight per year. So it's like 5 pounds per year. You see that? That's what the slope means. You're going to gain 5 pounds per year. So in words, what does the problem mean? So it's just, in words, it's 5 pounds per year. Okay? So the slope is 5 pounds per every 1 year. Just use your words. Weight in terms of pounds per year. Okay? Now domain. What's the domain? Now this is a little bit interesting, but let's have the graph stop right here, okay? What's the domain? How wide is the graph? 0 to 8, isn't it? Yeah. So the domain is 0 to 8 years. And the range, what's the range?
0 to 50.
Looks like it's about 18. I'm just guessing 18. You guys okay with 18? 18 to about 50 is pretty close. I'd almost go with maybe, yeah, I'd go maybe 52, right? I'm going to go 18 to maybe 52 pounds. Okay? All right, we're going to do the back side of this on Tuesday, and we're going to talk